Thank you for the invitation. My name is Sotiris Ioannidis. I'm a professor at the Techn University of Crete, and I will be presenting Elastic, which is efficient, portable, secure orchestration for reliable services. Yeah, this is one of the projects that is basically just starting. It started was designed to be March 1st. We got late in the game because we're in the reserve list, so it was a race against time to try to start as soon as possible. Disclaimer: we haven't had our kickoff yet. It's scheduled for later this month, so this is going to be this is like hot off the press, basically. The Gregorian Consortium, as others here, what we've tried to accomplish is good balance between academia and research, along with big industrial players and SMEs. So in our consortium, we have 5 academic partners, Techn University of Crete, we have IMEC, we have Aalto, we have Technical of Torino and Lund University. We have big industry like Ericsson and Thales, and our telecom provider is Telefonica. And we have 3 SMEs, Ultraviolet, Electrics, and Electric Machines. So that this balance is going to help us a lot in how this project progresses. Now, when we decided to bid for this call, we started by looking at problems that we'll be facing with 6G networks. So 6G is, of course, a huge opportunity, and it presents this huge leap in terms of performance, latency, reliability, energy efficiency, and it offers great opportunity for new capabilities and new network services to be deployed. Now, of course, with these great opportunities, there's a number of risks that come along and difficulties. So yes, you can have these new services, but you need to orchestrate them somehow. You need to make sure that they're secure. So these are the kinds of things that drove us to put together this proposal, and hopefully in our work, we'll be able to address a number of these issues and try to solve them as best as we can. Now, specifically, there are some very, very critical challenges that need to be addressed in order to be able to utilize 6G networks along with infrastructure of nodes and IoT and all that comes along in order to be able to run secure and reliable services. So we have provided an enumeration here the way we view them in our proposal. Of course, others may have different priorities, but from a security perspective and registration perspective, this is how we view things. So first of all, we require security of these lightweight and portable programs that live inside the network, and it has to be strong isolation between these components. There is need to perform this orchestration of services in an efficient and secure manner. So make these programs run to provide the service inside this network in a fast and secure way. There's a need for privacy preservation in the computation that we perform in these environments. And of course, we need to have these way to have portability across the nodes, across this variety of devices that may have different capabilities and different architectures. So these are the types of challenges that we feel we're facing in these new types of environments. So Elastic, if I can put this in a couple of sentences, what we're trying to do is enhance the efficiency and security of service orchestration within this highly distributed and heterogeneous environment from the edge to the fog to the cloud. And what we'll do in Elastic is focus on combining these new technologies, these key technologies, form this cloud native ecosystem in order to enhance service orchestration and security over the capabilities that 6G networks give us. Now, this mission, in order to be able to work on it, we broke it down into a set of, we believe, fairly concrete objectives. So we have set 5 objectives in this project. The first 3 are focused on various kinds of technologies that tie into the challenges that I just described. The fourth one is about the actual framework that we're building, along with the pilots that we're going to be testing our platform on. And finally, a more soft, let's call it, objective that has to do with dissemination activities, exploitation, standardization, sustainability of the project beyond the end, of course, of the project. So the first 3 objectives map on the technologies that we build. So the first one is about the isolation of the executables, the efficiency, the portability, and security of the code. The second one is about the function as a service and the orchestration of the various services that we build, making sure that we have data authenticity, data integrity, and trust. The third one is about privacy preservation and the architecture that we build, on how we build the execution environments. And as I said, the fourth one is about the integration of the platform, the implementation of the platform, the testing of the platform using the pilots. And finally, as I said, the dissemination exploitation. I do not have an architectural picture in this presentation. The point is to get to give you the sense of what an idea of what the project is doing. I don't want to go into details of the architecture. I just want to show you the overall scope of what we're trying to do and the tools that we'll be using. So I just wanted to abstract it a bit using this figure right here, showing you the tools that will come into play as we build Elastic. So these tools and functionalities, technologies, call them as you wish, map into the objectives that I talked to you about in the previous slide, and also the challenges I presented. So we have tools like WebAssembly, for example, that provides us with these very lightweight containers that we can run our code on. It's highly portable. It supports multiple programming languages. The execution is very light, so it's very well suited for the types of environments that we're looking at. The other thing is the serverless function as a service, which offers high scalability and very efficient architectures. It introduces scaling up and scaling down depending on the resources that you have in your network and in your nodes. And of course, it can reduce latencies. Thirdly, the other tool and functionality that we'll be using and building in our solution is the confidential computing aspect. So here we'll be employing things like trust execution environments in order to run our code on. So things like SGX for Intel, Trust Zone for ARM. I don't remember how it's called for RISC-V. The standard is actually being developed right now, but RISC-V is also one of the architectures that we'll be looking into. We'll be using techniques and technologies and functionality that the hardware gives us, like cryptographic operations. The CPUs nowadays provide a whole spectrum of hardware crypto, and other technologies that help us in code isolation and code protection, like control flow integrity or instruction set optimization.
So
and finally,
1 minute left.
Okay, so I'm almost done. Finally, things like extensible Berkeley packet filter, which is a filter that runs in the kernel and provides a way to control network elements. And all these things are going to be built on top of our framework. So very quickly, we have two pilots, as I said, they're being run by Ericsson and Thales. One is about the connected factory of the future, so smart factories, and it has to do with processing pipelines that we can build with nodes that live, for example, in a factory. So again, the technologies fall into this, and orchestration is required, trust execution is required, and so on and so forth. And the second one is about migrating traditional data center functionality that the data center lives in the basement. How do you migrate that on the cloud and make it secure, scalable, etc.? So with this, I'm done. Our website, unfortunately, is not live yet. It should be live, I guess, after we have the kickoff, and hopefully you guys are gonna visit it, see, and monitor progress. So with this, thank you very much, and I'll take your questions if you have any.
Thank you very much, Sotiris, for the interesting presentation. Your pilots really look interesting.